So now we're going to pay some more attention to inverse trig functions. And before I talk about inverse trig functions, I want to make sure we very briefly review what a trig function is and what it does. Right? The whole idea is if someone asks you about the sine of something, that effectively means that they are asking you for the sine of an angle. Right? And the sine of that angle is a ratio. Okay? So if someone says, what's the sine of 5, it means that you are to understand that 5 is an angle, and you are being asked for the ratio that's associated with that angle. Right? Now when we're doing inverse trig functions, someone will say, what is the inverse sine, which is sometimes written as arc sine. They'll say, what's the inverse sine? And when they ask for the inverse sine of something, it's the inverse function. It works backward. The thing that they are giving you is the ratio. This time they're giving you the ratio and are instead asking, what is the angle that would yield that ratio in the sine function? So please understand, when you're doing inverse sine, they are giving you a ratio. They're giving you a numerical value that you're working with, and you're coming up with the angle that's supposed to give you that. And we're going to talk about how we do this, how we estimate this, using the unit circle. So, some examples here, right? The first example I could ask is for you to approximate the inverse sine of 0.7. So this question is effectively asking, what angle would give us a sine of 0.7? Now think back to what you already know about the unit circle and how this works, right? Remember that sine is always associated with a y value. Right? The ratio that's associated with sine is y. So what this problem is effectively saying is, it's saying what angle would give you a y value of 0.7. So you can look over here in this unit circle and say, well, a y value of 0.7, that would be over here. Right? This angle seems to be 0.8. But I hope you've noticed that's not the only angle where this happens. Right? It also happens over here. Right? And it's not quite 2.4. It looks like it's maybe, 2.38. It's not my job here to find out what the exact values we're approximating this, right? But the idea is an angle of 0.8 and an angle of, roughly 2.38. Both of those angles would both give me a y coordinate or a sine value of 0.7. And so those two angles are both values of the inverse sine of 0.7. Okay? We can do a very similar thing for the inverse cosine of 0.9, right? We remember that cosine, in terms of its ratio, cosine is always referring to the x value. So this problem is effectively saying what angle has an x value of 0.9? Well, an x value of 0.9 happens here. In terms of angles, it looks like that's going to happen here, at about, 0.4-ish. And then also downward. And if you sort of think about what that angle has to be down there, the idea is whatever angle I went up to here, I'm going to be going down the same amount. So this angle here would be negative 0.4. And so those are two different values that you could get for the inverse cosine of 0.9. And I'm going to be very honest and upfront with you here. This should be a little bit troublesome. When we have functions, there's only supposed to be one value that we're getting back. For now, I'm just going to sort of gloss over that point. For now, understand any time I ask you for an inverse sine or an inverse cosine, you should be giving me two different values, two different answers to these problems, and I'll clear that up in later videos when we get to that point. So the next thing I want to talk about there with these multiple values is this idea of symmetry, right? And so I have it all lined out for you here in terms of what you need to have memorized. For the sine function, if the inverse sine of some ratio is an angle, right? So let's say you've already found one angle. How can you always find another angle, right? Well, the idea is you can always do it by taking pi and subtracting that angle. And let me try and show that to you sort of on a little unit circle diagram. Suppose that you've got your unit circle here. That was a horrible circle, but forgive me. And suppose you found that one of your angles was here, right? Like, you did your inverse sine and that was where one of the angles was. The other one will be over here, and the idea is that that angle, and this may get confusing, but bear with me. If this was the angle of the first one, then we could do pi minus theta to get the other one. I hope that made sense. The idea is that, you know, halfway around the circle is pi, so if you subtract off the original angle, this part that you have here will effectively be pi minus theta. If you're struggling to understand that, you might watch that section again, like rewind and then think through that again. If you think you've got it, or if you want to just try and move on, in English, the whole idea is that if you have the inverse sine and that gave you one angular value, you can find another one by subtracting the angular value you found from pi. Okay. Cosine is a little bit different and to be honest, easier. With cosine, if the inverse cosine of some ratio gives you an angle, you can find another angle that has the same like inverse cosine value by just doing the negative of that angle. And I don't know that I really need to read this one in English. You know, if you get one angular value, you can find another one by doing the opposite of that angle that you found. The previous slide, when I did those other examples, I hope made that process clear. And if it doesn't, then I'll illustrate it in the examples that I have coming up. So for this one, suppose you're asked to approximate the inverse cosine of negative 0.5. If you're up to it, you know, pause the video for a minute, try that one on your own, and then check the answer with me here. So let's do the inverse cosine of 0.5. So cosine is always associated with an x value, so I'm looking for the angle whose x value is negative 0.5. Well, an x value of negative 0.5 is here. If we sort of follow this up to here, and then follow it down as well, these are effectively the two angles that I'm looking for. One of them up there, one of them down here. Okay, so this one, this second quadrant angle I can find pretty easily. This is 2, this is 2.2, so that looks like about 2.1. So we could respond that an angle of 2.1 would be appropriate. Now, it may be difficult for you to guess what this angle all the way around here is, but it's not hard for me to say if this angle was positive 2.1, then going backward the exact same amount would give me an angle of negative 2.1. And those two angles would both have a cosine value of negative 0.5, so these are both acceptable inverse cosine values. Okay? So hopefully you got that one. We're now going to try out the inverse sine one. So the inverse sine of negative 0.8. Remember that sine is always associated with a y value, so we're looking for a y value of negative 0.8. So negative 0.8 is down here. We can sort of follow this over and follow this over. Okay. And so again, I'm looking for this angle here, and I'm looking for this one as well. Right? So this one seems to maybe be the most difficult one, right? What is this angle that we've got coming down this way? Well, again, you can sort of use symmetry to bounce these ideas around, right? If you sort of think about, well, you know, this one here, almost think about where the negative point is, you can even look at the positive 0.8 and see that that one's up here at about, you know, what is that? If that's 8 and this is 0.9, you know, we could say this is maybe 0.87, which means this one down here should be negative 0.87. And again, I'm being more precise than I need to be, but the idea is, great, we have a sense that this angular measurement down here is negative 0.87. Right? What about this one over here? Well, we could again sort of go up here and pull this value from here. You know, we could say that it's, you know, 2.2 or so, so this one here would be negative 2.2. But I wanted to sort of mention the shortcuts that we had on the previous page, right? We had said that another idea, another way that you can get these things, and these may be off a little bit here, but we said that you can, if you have one sine value, you can always find another by doing pi minus that value. Right? So what this is effectively saying then is you're saying, you know, 3.14 plus 0.87. If I sort of add these two things together, I'm going to end up with, what, 4.01? And on the one hand, you may be worried, like, oh my gosh, like, this one said negative 2.2, this one says 4.01, what's the deal with all of this? Remember, these are sort of just two different ways of thinking about the same angle, right? One of them we found, let me use a different color for this, one of them we found by going backward, I don't know if we can see this color, by going backward an angle of 2.2. The other one, I'm going sort of the proper direction around the circle, all the way around, sort of a total angular movement of 4.01. So those are sort of all different answers, all different possible answers for this thing. So I mentioned before that there's going to be 2 answers for all of them. There are actually infinitely many for them, because we could keep wrapping around the circle again and again and again to find other ones. In later videos, I will be explaining this in more detail in terms of how we're going to get more of them. Right now, I'm just looking at using the unit circle to find these values. So I did have two final examples, just because I wanted to give you guys, one more shot at looking at these things. So again, if you haven't tried them on your own yet, definitely try them on your own here. So first, the inverse sine of negative 0.35. So negative 0.35 is here. So those angles are going to be located here and here. Right, and if I sort of think about what these are, for that first angular value, I can sort of think at it by looking up at the positive value, finding that that's something like, maybe we'll call that 0.38. So this negative one down here will be negative 0.38. And for the other one, for this angle here, I'm going to go ahead and use that my sine trick again by saying that I could do 3.14 minus this value. And so when I add those guys together, I'm going to end up with 3.52. So these are 2 different angular values I could use. I suppose the other thing I could have done is I could have taken this value of 2.8 and simply used negative 2.8. That would have been another sort of acceptable value for us to go with. Again, if you're getting any of these, if you're seeing how I'm using symmetry to bounce around the unit circle, it means you're getting the idea of how this works. So now I'm going to go over and look at the cosine one. So we want the cosine of positive 0.65. So positive 0.65, x value is here. If we follow up, I'll have this angle, and down I'll have the negative version of the same angle. This one up here seems to be an angle of, I suppose approximately 0.83 or so. And then the other one, I just go this angle down here. I go with the negative value of that, negative 0.83. So those are my 2 values. So hopefully this has all made sense in terms of how we can use the unit circle to just get an approximation for these things. I just want us to have an understanding of how the inverse trig functions work, of what they're doing, of what they're using, and how we're working with these things.